Welcome to the AI Research Roundup. I'm Alex, and today we're looking at this paper from the Hugging Face trending list, published on the 23rd of June 2025, T 8 hours 40 minutes and 45 seconds .00000. This research, published just a few days ago, reveals a critical weakness in current models, that most lose 60 to 80% of their debugging capability after just 2 or 3 attempts. The paper is titled, The Debugging Decay Index, Rethinking Debugging Strategies for Code LLMs, and the solution it proposes is surprisingly simple, but very effective. The authors introduce a new way to measure this rapid decline and show that a strategic fresh start can significantly boost performance. Alright, so to measure this drop-off, the authors calculated the Debugging Decay Index for several popular models, and this table lays out those results. The key metric is the decay constant, lambda. A lower number means the model is more persistent at debugging. For instance, GPT 3.5 Turbo has a very high decay constant, over 1.3, so it fails fast. But a model like Codestral 22B has a much lower one, showing it can sustain its efforts for longer. This data pinpoints exactly when a model's debugging ability is likely to collapse. And these charts really bring that concept to life, showing the decay curves for 4 different models. The red line on each plot tracks debugging effectiveness, and you can see how steeply it drops with each new attempt. For example, GPT-4 Preview loses 50% of its effectiveness after just 1 try. The key thing here is the R-squared value, which is a statistical measure of how well the curve fits the real-world data. With values over 0.9, this high R-squared value confirms the exponential decay is a very predictable pattern, not just random failure. So knowing this decay is so predictable, the authors tested a solution. And these plots show it works beautifully. The solid line in each chart is the baseline, just letting the model keep trying. And you see that steady drop. But the other lines show a strategic fresh start. This is where they restart the entire process when effectiveness drops by 50 or 80%. Look at the spikes for models like DeepSeek Coder Vi 2. That's the fresh start, kicking in, breaking the decay, and boosting performance by forcing a new approach. This table then puts some hard numbers to those performance spikes we just saw. It compares the final accuracy of several models. The A0 column is the baseline. That's just letting the model debug continuously for 6 attempts. The A50 and A80 columns show the final accuracy when using that fresh start strategy, restarting after a 50 or 80% drop in effectiveness, respectively. Almost all the bold numbers show an improvement over the baseline, and for a model like Llama 3.18b, the accuracy jumps by 10%. So what this all tells us is that these models aren't just failing randomly, their debugging ability follows a predictable pattern of decay. The key insight here is twofold. First, we now have a tool, the Debugging Decay Index, to measure and predict this drop-off. And second, we have a simple but effective strategy, the strategic fresh start that can break this cycle and boost a model's final accuracy, often without any extra computational cost. It's a really practical finding. That's all for this paper. Thanks for tuning in.